How's it going, everyone? My name is Joshua Walters.
I'm David Joyner.
And today we're going to be going over friction and how that plays a role on rotating wheels.
To start, I'm going to show you an example of how friction affects a rear wheel powered bicycle.
And then after that, we're going to go over a vehicle that's a front wheel powered by the engine.
Alright guys, so this is our drawing as an example of what we just saw in the video. So in the video we had the pedal powering the rear wheel, which is what we have here, and as you can see that the wheel rotates in a counterclockwise direction. And what this is when it's rotating counterclockwise direction, there's an acceleration pointing to the right, and this is a force that the wheel is applying to the road. Now, that's the force the wheels are applying to the road. Now there's a reactionary force of the road onto the wheel, and this is a frictional force which opposes the direction of rotation. However, it pushes the bicycle overall in the direction we want to go. This is the overall centroidal acceleration of the bicycle, which is pointing to the left. That's also corresponding to the direction of the friction force of the road onto the wheel. Now, the front wheel, there's no power applied to it by the pedals, so this is a free rolling wheel. This only has a friction force opposing the direction of travel to the right. So as we said before, there's a centroidal overall acceleration of the bicycle to the left. This front wheel has a friction force pointing to the right, opposing the direction of motion.
Go for it.
Roll.
Alright guys, so what you guys just saw in the previous video was proof that the car was a front wheel drive car, and the reason was because someone was pressing on the gas while the parking brake was on, and you can see that due to the engine it caused the wheel to rotate in the counterclockwise direction, and that engine is causing an acceleration and a force to the right, which is acting on the surface. Likewise, there's an opposite force which is from the surface acting on the wheel, and that's the force of friction, which is going to the left, which is going to cause an acceleration to the left. The back wheel is in free rolling, so if there was no friction on the ground, it would be purely translating to the left. However, because we have this friction force from the surface to the wheel, then it's causing that back wheel to rotate in the same direction as the front wheel, which is counterclockwise. And that overall is going to cause the car to accelerate to the left.